useful when we can accept data into an array and maintain the array in a sorted order. We have here a school, and a school has students. Each student has a name, an ID, and a GPA. If you visualize what this struct would look like, it will look something like this, where you have a field for the name, the student's ID, and their GPA. We can make an array of this student struct to hold 100 students, and we can have a variable n to keep track of the number of students we have in the array thus far. And our goal is to maintain this array in such a way that it remains in sorted order, alphabetically by the student's name, throughout the entirety of the addition of new data into the array. So we see here we have Amy, Bob, Christy, Eva. The names are in ascending order. We start with the empty array, and we know, well, the empty array has nothing in it. And we add Ava into the array. So Ava is the first student that is enrolled in the school. And we put Ava in location 0. So n at this point is 1, because we have one student. So therefore 0 is in location n minus 1. Then we insert Zach into the array. So Zach is the second student who enrolls in the school. And if we maintain this alphabetically, Zach will go in location 1 in the array. So n increases to 2. N becomes 2, because there are now 2 students. And Zach is put in location n minus 1. Everything so far has been pretty simple. But now we want to insert Jack into the array. And we know that Jack needs to go between Ava and Zach. So how do we do this? The first thing that we do is we start up an integer pointer, I, and we can have I start at the n minus 1 location. And we ask ourselves the question, is the incoming student, we can call this student S. So is student S, is that person's name less than the name that is currently being examined, which is indexed by I? So if it is less than students I.name. If this is true, and of course less than means that we are comparing the names, and if Jack comes before Zach, if this is true, then we must shift Zach one space to the right. Not just shift him, but we actually make an exact copy of Zach, one space to the right. So it looks something like this. Like that. So in location 2, in the array there is an exact copy of Zach. And what we do is we take this I, we take the I integer variable, and we decrement it, so we move it to location 0. And we ask ourselves the same question. Is the incoming name, Jack, less than the name currently being examined in location I? So we examine Ava versus Jack, and we see that Jack is no longer less than Ava. So in that case, we do not copy Ava over like we copied Zach. Instead, what we do is we place Jack, the incoming student's name, in the I plus 1 location. So I right now is 0. I plus 1 is actually 1. So Jack will go and replace this copy of Zach. So Jack goes in here into index 1 in the array. If now we want to insert yet another student, Amy. So we know by examining this array that Amy must go at the very beginning of the array. So follow along with this similar procedure as before. Remember that we just added Jack. So that means that n increases from 2 to 3. So n was 2 before, and you would need to do an n++ to increment n from 2 to 3, which means that n minus 1 is on location 2. And we start I at that location. So you start I at the location n minus 1 in the array, the location of the very last student in the array. And we ask ourselves the same question from before. We ask ourselves, okay, is the incoming student's name less than the name currently being examined? So is Amy less than Zach? And the answer is yes. So we make a copy of Zach into the I+1 location. We make a copy of Zach just to the right of Zach. Copy and you paste there, like that. And we decrement our I, so we move backwards through the array, like this. And we make this comparison now. We compare Amy against Jack, and we see that Amy is still less than Jack. So we do another copy. We copy this I, this student in location I, into the I+1 location, which means that this Zach here is going to be deleted and is going to be overwritten by Jack. So we delete Zach and we put a copy of Jack in Zach's previous location here, like that. And we decrement our I yet again to here. And we do yet another comparison. We compare Amy against I, which is Ava right now. And we see that Amy is still less than Ava, which means that we do yet another copy. We copy Ava from the I into the I+1 location, overwriting this Jack here. So we get rid of this Jack, delete, and we put Ava. We put a copy of Ava into the I+1 location where that Jack was. Notice that throughout the running of this algorithm, that there may be duplicate data in the array. So we see here that we have Ava once in this location and we have her again in this location. And before, well, you would have seen that in the previous runnings of the algorithm as well. So now what do we do? Well, Amy is still less than Ava, so we must decrement our I yet again. So we decrement our I. I goes from 0 to location -1. But there is no -1 location when you're dealing with an array. So that's an indication that we should stop. And it means that we should actually put Amy in the, again, the I+1 location. So Amy should go where this Ava is. So we will put Amy where this Ava here is. Amy goes there. And that is how you accomplish the insert in place, where you have some data that is already in some either ascending or descending order, and you would like to insert some new data such that the array is maintained in that ascending or descending order. So how would you accomplish this? Let's say that you have this incoming student S. So S is some new student struct variable that you want to add into this array. Well, you need this integer variable I, so you say I assigned to n-1, where n is the number of students in the array thus far. And you say while. While what? Well, there were two things that could cause this process to stop. The first thing was if I had reached -1. We saw that in the last case with Amy. So if I reach -1, if my I reaches -1, or I could say while my I is greater than or equal to 0, then keep going. And what? What is the other thing that causes this process to stop? We also stop when the incoming name is no longer less than the name currently being examined at location I. So that's the other thing that could cause us to stop. So and, right, we will continue while the incoming name S, so that's s.name, we must access the particular field in the struct, is less than the students, so this is the students array at location I dot name. While this is true, what do? We make the copy, right? That's what these red arrows were indicating. We copy from the I into the I plus 1 location. So what do we say here? We say students I plus 1 assigned to students I. And then we say I minus minus. That is the act of I decrementing and going backwards through the array. I minus minus. That's our while loop. We can break out of this while loop in one of two ways. Either we hit -1, which means that this condition is violated, or the incoming name is no longer less than the name being examined at I. Either way, we did the exact same procedure. What do? We put the incoming student S in the I plus 1 location. So we say here, we say students of I plus 1 assigned to S, where S is that new incoming student's name. Finally, you will want to increment your N because you have now accepted a new student into the array.